Here is my second DER of grade 11, the persistence of vision, or the POV-DER. The persistence of vision DER is a build that consists of two main parts, the code and the build itself. Beginning with the build, there are 5 main components: the dual 14-segment display, the 2 shift register ICs, an NPN transistor, and finally a PNP transistor. To build the first portion of the circuit, a square wave signal must be built. A circuit diagram is on screen. From there, the IC chips must be daisy-chained together. Then the distinguished outputs from the ICs must be wired through the resistor networks and into their designated 14 segments display pins. The dual 14-segment display is a complex display consisting of only 18 pins and consists of 28 LEDs in total, not including the decimal point. As a result, every LED is wired directly to their counterpart on the other display. Yet this is where the POV square wave signals part of the circuit comes in. The transistors break up the high and low signal into 2 different wires outputs. When one is high, the other is low, and vice versa. These rapid changes each are wired to one 14-segment display and rapidly turn them on and off, allowing them to display different values. This can't be seen with the human eye, but with this success, there is also a problem, that being ghosting. Ghosting occurs when there is a slight error, and while not as visible, the opposite character will be slightly displayed on the wrong display. This can be fixed, though, with a simple change, by wiring the output-enabled pins of the 595 IC chips to the Arduino, and wiring them low before shifting out, and high directly after. On screen is the first part of my loop statement, where the serial monitor interacts with a person typing any 2 English letters. The 2 values are instantly converted to uppercase letters, then written back in the monitor. Next, the letters need to be found within a switch statement, where once found are matched with the corresponding alphabet map, which then gives us the ASCII values of each letter. Finally, the latch pin and output enabled pin are wired low and shift out occurs, where the bit shifting commences. After completion, the output enabled pin and latch pin switch pin are all wired high. This also prevents ghosting.